These are the notes for AP Calculus on the topic of volume using the disk method. So, to generate this formula, it comes from the volume of the disk, which is really just the same formula as the flattened cylinder here. So, got some circular disk here, and it's got some thickness to it. That, kind of like a pancake there. Then the volume of that would just be the area of the disk, which is pi r squared, just the area of the circle, times the width or thickness. And in this case, the width or thickness is going to be dx. So, all we need to know here is the volume of one of those, and then we can integrate it on whatever interval we have, and then that'll give us the volume of the entire three-dimensional shape here. So the formula, the disk method, sometimes on these there's solid disk, and sometimes they have a hole in it. So because of that, the formula, you can pull the pi on the outside, that's a constant, and you just have the radius squared, minus if there's any inner radius, r sub 2, you have to subtract that radius squared. So R1 here represents the distance from the axis of revolution to the far end of the rectangle, which we'll see. And R2, your inner radius, is the distance from the axis of revolution to the near end, or close part of the rectangle. So sometimes our disk will look more like this. In this direction here. Where the thickness is dx. And sometimes so that R1 is the radius of that disk. But then some of these will have an inner radius. If there's a hole in these disks, then R2 will represent there to there. That distance right there, that'll be R sub 2, the radius there. So we're basically taking the air volume of the outer disk and subtracting the volume of the inner disk, if there is one. Not all of them will have R sub 2, but if there's any gap there, if there's any hole in our three-dimensional shape, we'll have to use an R sub 2. So let's take a look and see how this works on some example problems. We're going to do the first two without a calculator and the second two with calculator. So it says sketch the graph of the bounded region. Okay. Then set out the integral to find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the indicated axis of revolution. And then integrate to find the volume. So on this one, we've got some simple graphs here, so let's just go ahead and sketch the graph of this. Y equals the square root of x. Some simple things to plug in there would be 0. You get 0. If you plug in 1, you get 1. If you plug in 4, square root of 4 is 2. So that would look like that. So y equals the square root of x. Then we've got x equals 4, which is just a vertical line. And then we've got y equals 0, which is just our x-axis there. Okay, so you can see the region they enclose is right in here. But we're not just finding the area of this region. What we're going to do is take this region, right here, again drawing a representative rectangle with dx. And we're going to revolve it, since the axis of revolution is the x-axis. So we're going to take that, here's our x-axis, and the way you represent the axis of revolution is just a circular arrow like that. It shows revolving around. So can you picture, we're taking this region, picture it coming out of the board out here, and revolving around the x-axis to form this three-dimensional shape, which is kind of going to be similar to a cone, except a cone is formed when this is just a triangle. And this is, as you can see, it's curved here, it's not a triangle. So it's not a curve, but it's similar to the shape of a triangle here, well drawn. Okay. So the way we can do this, again, the integral for the volume here. So with the disk method, you have pi on the outside. And the integral from start region starts at 0, stops at 4. Just like you do area. And then your R1 and R2, if we're looking at the graph here, the radiuses always start at your axis of revolution. R1 goes from the axis of revolution to the far end of the rectangle. You can see in this case, R1 of x would be the top one, square root of x, minus the bottom one, which is just 0. So in the form that's R1 squared, so the square root of x squared. And then on some of these you have to subtract an R2. But notice on this one, see how there's no gap between the rectangle and our axis of revolution, no matter where you go? So on this one there is no R sub 2. There is no hole in this shape. So we don't need an R2. Sub 2, this is where it's not needed. Okay, so it's just this times dx. So just pi r squared. Coming from the area of the circle times the thickness dx turns it into volume. So let's go ahead and integrate this to find our volume. So first you can square that to make it simpler. Square root of x squared is just x times dx, and then go ahead and integrate it. Gives you x squared over 2. Evaluated from 0 to 4. And again, I like to turn that line into the vertical line in the brackets there, so it's easier to have the pi on the outside there. And then substitute 4. 4 squared over 2 minus, you plug in 0. 0 squared over 2. So 4 squared is 16, divided by 2 is 8. That's just 0, so it's 8 times pi, so you get 8 pi. And this would be, there's not specific units, but it is volume, so it's units cubed. You don't have to put that, just to keep in mind that we'll find something 3-dimensional now instead of just 2-dimensional. Okay, let's take a look at another one without calculator. Actually, I forgot. We're going to actually use our calculator on all 3 of these. I thought it was just 2. I was 2. But it's actually, we're going to use calculator on this one as well. So you can see it's not easy to find the points of intersection there. So we use our calculator on 3 of these. So starting with this one, let's go ahead and enter these in. Again, I'll show it on both the 84 and the Inspire. So on the 84, let's turn on. Let's go ahead and enter in x squared minus 6x plus 11. And then for g of x 5 times the sine of 0.5x. And let's change our window size. Let's make it -1 to 7 for the x minimum and maximum. And y minimum, let's make that -1 to 7 as well. I like to have the x minimum and y minimum -1 instead of 0, so it's easier to see where the x and y axis are. And let's go ahead and graph these. So there's the first one, there's our parabola, and there's g of x, our second one. So even though the calculator graphs it for you, you still want to draw it on paper here. Or you may not want to, but you should draw it on paper. Set things up correctly. So there's f of x, like that. It's just a rough sketch. And start a little further, I think. F of x, and then g of x. Okay, just enough so you can see the region enclosed. And so you can see we're going to need to find 2 points of intersection here. I'll call those A and B. So let's use our calculator to find both of those. So you just go second calc, number 5, intersect. First curve, there's only 2 enter, y1, enter. Second curve, y2, enter. Guess, either type it in or move your cursor close to this point of intersection. And we get A as 1.684. .4593. And let's store it in our calculator. Have to write on paper, alpha A. And then let's find the other point of intersection. So again, second calc, number 5, intersect. First curve y1, second curve y2. This time, guess over here. So move the cursor over there or type it in. Enter. And B is 4.419. .1814. So let's store this in our calculator. Second quit, store alpha B. And then let's go ahead and set up our integral for the volume here. So, again, let's draw a representative rectangle here in this region. And again, this one is revolving around the x-axis. So, again, the axis of revolution tells you where the center of your figure is. So we're taking this region and coming out of the page edge towards you, and going around and around our axis of revolution. So R1 and R2 both start at the axis of revolution, which is the x-axis here. R1 will go from there to there. So the top curve there is, one on top is g of x minus the bottom one, which is 0. R1 would be g of x minus 0. And this one, notice there is a gap between our region here, between the lower part of the rectangle and the axis of revolution. So there's going to be a hole in this, so R2 is needed on this one, and it would be the close end of the rectangle to the axis of revolution. So there's R2. So R2 of x, R sub 2 of x, would be, again, the one on top here is f of x minus the one on the bottom, just 0. So the setup on this one for the volume would be pi again on the outside, integral from a to b, which we figured out, and the outer radius squared minus inner radius, which is r sub 2 f of x squared. And then don't forget the whole thing, turning the volume has to be times the thickness of those discs. So let's see how I put this in our calculator there. And again, make sure they're squared separately. The final mistake is students will go g of x minus fx and then square the whole thing, which gives you a different answer, which would be incorrect. So in our calculator, and I'll do this in the Aspire in just a second, you would just go math, function integrate. So what we want to integrate is g of x squared minus f of x squared.
So that's y2 squared minus y1 squared, then comma x, comma lower limit is alpha a, comma upper limits alpha b. And what I forgot to do, I should have done pi times this. I forgot to multiply by the pi, so I can do that right now. And just go times, and then pi is right there. Okay, so we get 122.034 or 035. Alright, let's take a look at the same thing now using the Inspire. On Inspire, let's create a new document, add graphs, and then F1, be x squared minus 6x plus 11, and f sub 2 would be 5 sine of 0.5 x. And let's change our window size. Window zoom. Let's make it -1 to 7 on x minimum and maximum, and -1 to 7 on the y minimum maximum. And that we can see our region really well. And then let's go ahead and find our points of intersection. Menu, analyze graph, intersection, lower bound, upper bound. There it is, and store it as A. And then let's find our other point of intersection. So menu, analyze graph, lower limit, upper limit. See, it's right there. You can move it around if you need to. And then let's store as alpha b, or not, we don't have to do the alpha here, sorry, just store as b. And then document insert calculator. And you can put the pi out in front, which is what I forgot to do on the 84. And then the integral from a to b. And we'd have parentheses here. See, our integral was at f1 squared first. Actually, no, it's g of x squared first. So you have 2. Oops. Of x squared minus, in parentheses, f1 of x. Should put the squared in the right place. We're not squaring the x, we're squaring that whole function there. And then times dx. Since I put the pi out in front, I don't have to worry about multiplying it later. Let's see if we get the same answer that way. All right, let's take a look at another example. So far we've just revolved around the x-axis, but really it doesn't have to be the x-axis you revolve around. So let's take a look at a couple where it's not the x-axis. So let's go ahead and put these in our calculator. Again, I'll do an 84 first, so I'm going to clear these out of here. And we've got negative out in front, so that's with the parentheses there. Negative natural log of x. Notice the 7 is not inside the natural log, so close parentheses, then plus 7. And then y2, we've got 2, and then to raise it to an exponent, you use the caret button for exponent, and then exponent is 0.6x. Let's go put in parentheses just to make sure that whole thing is the exponent. There we go. And then let's change our window size. Notice x equals 1 we're not going to need to put in because that's not a function, it's just a vertical line. So we can just graph that by hand. So then our window size, let's make the x minimum -1 to 6. Again, when you're doing these on your own, you just have to kind of play around with the window size until you can find where you can see your region well. Sometimes you have to make it bigger, sometimes smaller. -2 to 9. So there's the first one, and there's the second one. So again, let's do a sketch of this on paper here. First one looks like this. Y equals negative natural log of x plus 7. And then the second one is y equals 2 to the 0.6x. So with just those two alone, notice there is no region enclosed, but we have one more. We also have x equals 1, which is just a vertical line. Right here. Oops. So now you can see this is, we've got a region enclosed right here. So, draw a representative rectangle there. Let's go ahead and set this one out here. So notice, since we know our region, you can see because of x equals 1, our region starts at 1, so we don't need to find points of intersection there, but we do need to find that point of intersection right there where the region stops is A. So we use our calculator here, we'll set up the find A. Let's go ahead and set up the interval though. Let's find our R1 and R2. This time though, notice our axis of revolution is y equals -2. So let's draw that as a dotted line so it doesn't confuse where the region enclosed is. So y equals -2. Right down there. So that's what we're revolving this around. Instead of just the x-axis. So your R1, R sub 2, again they always start at the axis of revolution. That's where the figure is centered at. And R1 goes from axis of revolution to the far end of the rectangle, right there. So R1 of x, the top one is negative natural log of x plus 7, minus, this time the bottom one is not 0, the bottom one is -2. So it's minus -2, which you can see is like plus 2. And you can see why that would be, because it's really adding 2 to what it would be if you're just revolving around x-axis. And R2 is needed because there's a gap between our rectangle and our axis of revolution. So R2 would go from the axis of revolution to the close end of the rectangle. That's the radius of the hole. So R2 of x, the one on the top there is 2 and 0.6x. And then minus, again, the one on the bottom is -2. So again, it's like plus 2. So when we set up our integral, to find the volume, it's going to be pi times the integral from the region starts here at 1 and stops at A. And we'll have R1, which is negative natural log of x plus 7 plus 2. You could combine the 7 and the 2 to make a 9, but it's actually easier to put in your calculator. It's like that, because this one's already in our calculator. Minus R sub 2 is 2 to the 0.6x. Again, minus -2 is like a plus 2.
then the whole thing again times dx. So let's see how we enter that in our calculator.
And let's find that point of intersection. So to find the point of intersection, just go second calc, intersect, first curve y1, second curve y2, guess over here. And you can see that's 4.134. (0909).
Write it down on paper, and let's store it in our calculator now.
Oops. Second quit, and then store alpha a. And when I put this in as a, it overwrites the previous a value I had stored in there. It's no longer there. So if you want to keep that other a value in, use a different letter. And then just go to math, function integrate. So here we had f1 of x, sorry, y1 plus 2 squared. So put a parentheses, and then it'll be y1, and there's minus negative 2, so plus 2, close parentheses, squared, minus, the other one was the 2 to the 0.06x plus 2 squared. So that's y2 in our calculator. So y2 plus 2 close parentheses squared. And then you put a comma, x, comma, lower limit is 1, comma, upper limit alpha a, close parentheses. And again, I forgot to put in the pi, so what I'm going to do here is right at the very beginning, I'm going to go second insert, pi, and then times this. There you go. So now I don't have to multiply by pi at the end. And we get 380.786.
Again, it's not specific units, but it is volume, so it's like units cubed. Now let's do the same thing on the Inspire real quick. So on the Inspire, I'm just going to document, new document. I'm not going to save the old one. If you did want to save it, you could save it to come back to it later if you needed to. So add graphs, and it'll be negative out in front, so negative, that negative button in parentheses again. Natural log is right on top of the e to the x button, so control natural log of x plus 7, and then for F2 be 2, and then on the Inspire you can hit this button and it puts the exponent up where it looks like an exponent, 0.6, or you could just do 0.6 also, x. Sure. And again, let's change our window size here. Window zoom, window settings. Let's make the x minimum -1, x maximum 6. And the y minimum -1, or sorry, let's make it -2. Y maximum 9. Okay, so now we can see origin. Again, we don't need to graph in x equals 1 over here. And to find our point of intersection, menu, analyze graph, intersection, lower bound, upper bound, there it is right there. Store as a.
And then just go document, insert, calculator. And our integral here, again, we can put the pi out in front. Times integral from 1 to a. And it was f1. Oops, let's put a parentheses here first. Of x squared minus f2 of x. Oops, I forgot to put the parentheses again. Open parentheses so we can square it. Oh, and actually it wasn't just f1, it was f1 of x plus 2, wasn't it? So let's put it, sorry, plus 2 squared, and then parentheses f2 of x plus 2 squared, and then times dx. And see, we get the same answer that way. All right, let's look at one more problem with the calculator. So on this one, let's go ahead and again use the 84 first. Let's go ahead and put these in. So clear these out. So it'd be 3 arctangent of x, and then plus 5, and then x squared. And let's change our window size. Let's make the x minimum -3, x maximum 5, x minimum -1, sorry, y minimum -1, y maximum 11. And graph. Okay, so again, graphs them in the order you type them in. So there's the first one, and there's the second one.
First one, f of x, something like that. G of x is just our standard parabola. Okay, so you can see the region enclosed. It does have to be a great graph, mine's not there. But as long as you can see the region enclosed, again, if you have a choice, draw your rectangle in the first quadrant. It's easier usually to figure things out that way. Dx. And this time, our axis of revolution is y equals 11. So, let's go ahead and draw that in as a dotted line. Up here. Okay, so that's what we're revolving this around this time. So we're drawing a little circular arrow. So we're taking this region, it's coming out of the page and revolving around our axis of revolution to form a three-dimensional shape. So we're going to need to find 2 points of intersection, A and B. The region starts and stops. So we'll find those. And let's write down what R1 and R sub 2 would be. So R1 would go from the axis of revolution to the far end of the rectangle. That's why I don't say it to the top or the bottom, because it depends on what your axis is. Sometimes the far end is the bottom of the rectangle, sometimes the far end is the top of the rectangle. So that would be R sub 1. So R sub 1 of x. Again, to get that distance, you take the top, which in this case is 11, minus what's on the bottom of R sub 1 is g of x. And this one, you would also need an R sub 2 because there is a gap between our region here and the axis of revolution. So R2 would go from the axis of revolution to the close end of the rectangle. So r sub 2 of x, again the one on top is 11, minus the one on the bottom is f of x. Again, we do the one on the top minus the one on the bottom for these vertical distances, because the one on the top has the bigger y-coordinate. And so we can set up our integral here for the volume. Be pi times integral from a to b, r1 squared, which is 11 minus g of x squared, minus r2 squared, which is 11 minus f of x squared, all times dx. So that's the setup that will give us the correct volume. So always make sure you write down your integral correctly first. And then, let's use our calculator for the rest of this here.
So on the 84, let's find our points of intersection. Second calc. Intersect. First curve, enter. Second curve, enter. Guess. I don't want to move my cursor over, so I'm going to type in, I think those intersect, I'm going to guess at -2. So you can just type in -2, and it'll take you right there. And
we get negative 1.449.
.058. And let's store that in our calculator. That's alpha A. And let's find the other point of intersection. So second calc, intersect, first curve y1, second curve y2. Guess, again, I don't want to keep moving the cursor over there, so I'm going to guess those intersect over there at 4. Okay, so it's closer to 3 there.
So that's okay, as long as your guess is closer to that point of intersection than the others. So B is 2.955.
.2548. And let's store this in our calculator so I can quit. Store as alpha b. And then we can go ahead and integrate this. So math, actually before we do that, I'm not going to forget here to put the pi first. So second pi times math number 9 function integrate. And then we want parentheses, because we want to take the 11 minus g of x, which was y2, close parentheses squared, minus, open parentheses, 11 minus f of x, which was y1, squared, and then comma, x, comma, lower limit is alpha a, comma, upper limit alpha b. Close parentheses. And we get 761.302.
Again, we're talking about volume here, so it is units cubed. You don't have to put that, we aren't given specific units.
All right, let's look at the same thing on the Inspire now. So on the Inspire, again, I'm just going to make a new document. I'm not going to save the old one here. You can if you want to come back to it later. And then add graphs first. So I'll type these in first. We've got 3 arctangent, which remember is the same as tangent with a -1 on your calculator, of x plus 5, and then x squared. And again, I'm changing my window size, so menu, analyze graph, window, zoom window settings. Make it -3 for the x minimum to 5 for the x maximum, y minimum -1, maximum 11. And then let's find our points of intersection. So menu, analyze graph, intersection. Lower bound, upper bound, there's the first one. Store as A. And then let's find the other point of intersection. Menu, analyze graph, intersection. Lower bound, upper bound. There's B, stored as B. And then we can go ahead and open up calculator. So insert calculator, this document. And then here, let's go ahead and go pi times the integral from A to B. And then open parentheses. So it's 11 minus, is it g of x first? Yeah, it was g of x first. So that was F2 in our calculator. Whole thing's squared. Make sure you square this, not the x there. Minus, open parentheses, 11 minus f of x, which was y, which was f1. And make sure you don't square the x, square that 11 minus f1 of x. It already put the parentheses for you around there, and then times dx. And you can see we get the same answer using the Inspire. And that concludes the notes for AP Calculus on the topic of volume using the disk method.